Hey, so in this video we'll be going over question 6 and 7. Let's start with question 6. Okay, question 6 is asking us to find where cosecant of theta equals to 2. Well, this question we're going to use two things. Number one, which is the fact that cosecant is 1 over sine, so in this case it's 1 over sine of theta, and we just set it equal to 2. Okay, so now we're trying to find um, where 1 over sine of theta equals 2, and that's when sine of theta equals to a half. And in this case, we're going to be using the second thing, which is the unit circle. We'll be looking at the unit circle to see where sine of theta equals to a half. We see that equals to a half in two places over here, where it's where theta is pi over 6, and there where theta is just 5 pi over 6. It's not going to equal to a half anywhere in here because y is, or sine of theta is going to be always negative down there. So the answer would be theta equals to pi over 6 and 5 pi over 6. Some people might still be confused because I'm sorry, I don't know what just happened. Okay, some people might be a bit confused because they're not sure how I came up with the fact that sine of theta would equal to a half. To do this, we can just solve it as an inequality, for example. So let's set sine of theta equals to x. Let's consider sine of theta as x. And then we can say that we have 1 over x equals to 2. If we solve for x, we would get x equals to a half, and that's why I said at the beginning that sine of theta would have to equal to a half. But most people wouldn't need to go through this because it's just obvious that 1 over a half would equal to 2. And that's why we picked um, half as what we use to find the answer. I hope that's making sense. Now let's move into question 7. Question 7 is asking us to sketch the graph of this function and find all of its properties. Okay, the way I prefer doing it is find the properties and then sketch the function. Okay, so first we see that we have a 2 outside of the parentheses. Let's distribute that. So we have, I have no idea what happened. Okay, so then we have 3 cosine of 2x plus pi. Okay, for this question we're going to be using the generic formula for cosine and sine, which says that a cosine of bx plus c plus d. In this question, a is the amplitude. B helps us find the period because the period equals to 2 pi over b, and c helps us find the period shift, I mean the phase shift, and d helps us find the vertical shift. Okay, now let's go back to the original question, which is 3 cosine of 2x plus pi. We see that there is a 3 at the beginning, so amplitude equals to 3. And then we see that the b equals to 2. Therefore, the period would equal to 2 pi over 2 because the period is 2 pi over b, so the period would just equal to pi. And then we see that we have a c, which means that the phase shift is not gonna be 0. So to find the phase shift, we have to solve everything that's inside the parentheses for x. To do that, we can set 2x plus pi equals to 0, and then we solve for x, so 2x would equal to negative pi, divide by 2, divide by 2, x would simply equal to negative pi over 2, which means that the phase shift equals to pi over 2 to the left. Hopefully this is making sense so far. Right. There's many ways that you can graph this, but I'll show you the way I prefer graphing it. So the first thing I do is I start by just graphing like the normal form function of cosine, just so I know where to go from there. So let's start by doing that. Cosine would go from 1 to -1 and pass the y-axis at 1, and it would have a period of 2 pi, so this would be 2 pi, and this should have been going down until, 1 second, let's make this -1. Okay, that's how the normal cosine would look like. Now we have an amplitude of 3, a period of 2 pi, a period of pi over 2. Keep messing this up. Yeah, the period is just pi, and the shift of pi over 2 to the left. Okay, the way I prefer doing it is first I would graph it without the shift of pi over 2 to the left. So let's do that real quick. It's going to go from 3 to -3, and it's going to be much narrower because the period is, the period is pi. It's going to look something like this. I know that this is nowhere near perfect, so that's why I made sure I had the graph ready for you. Okay, this is the graph without the phase shift of pi over 2. Okay, we can see that the amplitude is 3, as we said, it goes from 3 to -3, and then the period is pi, just like we said. And then we know that the phase shift is pi over 2. So pi over 2 would just move this whole thing to the left. Okay, let's just keep going. The video cut for some reason. Let's just go back to what I was saying. Alright, so I was saying that, as we said, the amplitude is 3 because it goes from 3 to -3, and as we calculated the period was pi, and we can see that over here. And the only thing missing now is the phase shift of pi over 2 to the left. The phase shift of pi over 2 would just move this whole thing by pi over 2 to the left, so the axes would kind of be somewhere in here, and we can see that in the next picture. Everything just moved by pi over 2 to the left, so wherever we had a pi, it became pi over 2 because we subtracted pi over 2 from pi, and that's it. This would be your final graph. This is how you would get it. Okay, now we move into the next question, which is question